Hi everyone, I'm Armando. I'm PhD student in computer science from Federal University of Ceará, Brazil. I want to talk about technical debt in large-scale distributed project and industrial case study. My special thanks to my advisor Lincoln Rocha from Federal University of Brazil, Ricardo Brito from Ericsson, and Zhixiong Gong and Feng from Berkeley Institute of Technology from Karlskrona, Sweden. It's necessary to explain some points to justify the motivation of this study. When you work in a global software engineer project, you observe that it is a complex environment to manage. Nowadays, we can observe that technical debt issues are a factor to time consuming in the maintenance of the system. It's very important to manage technical debt to avoid software degradation. Technical debt management is in large projects can be more complex. After that, we identify the following problem in this context. There is no investigation enough on the technical debt accumulation in large-scale global distributed software. Our goal in the following. We conduct an industrial case study in Ericsson to understand what factors are related to the TD accumulation in large-scale GSC project. The main question in this study is, what factors are related to TD accumulation in large-scale GSC project? By answering the question, we can get more details about these factors and work on a future solution to decrease TD accumulation in this context. In this topic, we talk about the methodology of this research. First of all, we talk about the case and unit analysis. The case and unit analysis is about the telecommunication software product developed by Ericsson. It's a 24 years several technology changes, for example C++, Java and others. In this project, developers work through the USA, Sweden, Italy and India. You can observe a cross-function team from 4 to 7 developers. The project managers use a mix of plan-driven and agile across the sites. We use data from 33 product customization. Each PC takes from 1 to 6 months of work. In this topic, we talk about the variables in data collection, the research design. About the variable and data collection, we choose the following variable: technical debt, task complexity, lead time, global distance, total developers, and team maturity. For technical debt, we use repository mine to collect amount of dollars using SonarQube. For task complexity, we use interviews with software architect to get how complex is a task. For lead time, we use architecture. We use archive research to collect the total time to deliver a task. In case task scaling, we use archive research to collect the capacity of the task resized according to the increase of demand. For global distance, we use archive research to collect the measure of complex communication among the sites. For total developer, we use archive research to collect the amount of developers in each task. And finally, for team maturity, we perform the interview to check the level of the whole team deliver the product. In this topic, we talk about the data analysis. For data analysis, we use statistical tests to validate the data, and we employ hierarchical multiple regression analysis to understand the relationship between selected factors and TD accumulation. We divide the results of this research in 2 moments. Firstly, we talk about regression analysis assumptions, and secondly, we talk about the factors related to TD. About the regression analysis assumptions, first we use a box plot to identify unusual points, when you can observe that only one outlier is removed from the data. After that, we use Spearman rank and test linearity to identify the factors correlated to technical debt. As you can see, we identify lead time, task complexity, total developer, and task scale as related to technical debt. After that, we use test independence to check the autocorrelation of the data. We use test normality to check residuals are normally distributed, and we use test multicollinearity to validate the model. And finally, we use regression analysis. We use a regression model to analyze the correlation between the variables, the factors, and the technical debt, as you can see in this formula. The second one is the factor related to TD. As we can see, the interview with software architecture confirmed that 4 factors, task complexity, lead time, total developers, and task scale are related to TD accumulation. We observed that task complexity has strong relation to TD since complicated tasks tend to have more debt. If the complexity increases due to change in a software structure, it can cause potential extra work to maintain the software. The longer it takes to complete a product customization development cycle, the higher the TD. Also, regarding task scaling, we observe that the size of TS increase, the amount of TD tends to decrease. So, in the case of total developer, the total number of developers in a software project is critical factor in GSE project. Also, regarding global distance, although we did not identify a statistically significant relationship between DD and TD accumulation, but it's a very important factor that can be investigated in the future. Even the interview also mentioned team maturity, although it was not statistically significant related to TD in our result. This is another factor important to get more details in the future studies. Finally, to wrap up this presentation, we have the following conclusion. The overall conclusion is that TD accumulation strongly correlates with specific factors of GC. We have the following implication for researchers. It's necessary to conduct similar research in other companies to learn more about the accumulation of TD. For practitioners, try to avoid complex projects and subdivide them into less complex projects as much as possible. Finally, we plan to continue investigating other cases in Ericsson to get more evidence about factors related to TD. Thank you very much. If you have any question, you can do by platform Discord or send an email or send message to me. Thank you very much.